All right, here we go. 2-4, day 3. Oh, yep, 2-4, day 3. That's because I'm zoomed in a little bit. We have to do variance and standard deviation again for grouped data on the calculator. Okay. So, we're just going to jump right into an example. And we did mean for group data. Remember, it was an estimate because we didn't have all the actual data values and we just used midpoints. But this one we actually have the values. So it's going to be two ways to do it. So they did a survey of the number of kids per household, and then the frequency. How many homes have that particular number of kids? So the number of kids per household ranged from 0 to 6. Okay, and the frequencies. 10 of the homes had no kids. 19 homes had 1. Then 7. Then 7. 5. One house had 5 kids and one house had 6 kids. It's crazy. Okay, and this was, what was this? This was a sample of homes. I would like you to find the mean, variance, and standard deviation for the number of kids per household. Okay, and we're going to use the 1-var stats. We're doing the shortcut. We're not going to do the long way here. Okay, method 1, which I don't recommend. I don't know, because if you forget the shortcut way, you can always go back to the long way. So, this would be the long way. We're not actually going to do this. This would be the long way. We wanted to find the average number of kids per house and the variance and standard deviation. Well, how many households did I get to? 50 households. So, the long way would be to enter the 50 values into list 1.
Wait, isn't it not 50 households?
Nope, this is the number of kids. This is how many. 10 homes had no kids in it. 19 of the homes had 1. So this is how many pieces of data I collected.
Okay.
So I collected 50 pieces of data. So the long way would be to enter the 50 numbers into list 1. That would mean putting in 10 zeros, 0, 0, 0, 0, 0, 0, 0, 19 ones, 1, 1, 1. See how that would be obnoxious? But it could be done.
That's what we're going to have to do on quiz, correct?
That's not going to be this obnoxious, though. But because it's grouped like this, and because we've got good programmers, they know you're going to be dealing with group data. So method 2, they've programmed the calculator to deal with this. So what you do with group data is you enter the X values into a list. We'll say list 1. Then you enter the frequencies into a second list. So we'll say L2. And then I'll show you what to do from there. So this alleviates us having to enter 50 pieces of data. So stat edit, clear out 2 lists. Oh, chop, chop, turn on the TV. Okay. Everybody, I still hear some more buttons clicking there. Okay, like I said, the programmers built it so that now when you go to one-var stats, normally we would just hit our list and then it would average up the numbers in that list, but that's not what we want it to do. We want to look at the frequencies. So what we're going to do is put in our X list first, our X list, comma, frequency list. So in our case, it's L1, comma, L2. When you put that second list in, the programmers automatically said, oh, that's the frequency for the first list. So when you put in two lists, it's just the way it's programmed in. We like Texas Instruments programmers. It will assume that you have 10 zeros, 19 ones, you know, the way you have it paired up. So let's try it. Stat.
We don't
Wait,
put
do I-
0 in?
No. You just go stat, over to calc,
Wait, so I quit. right?
quit, yep, quit. And then over to calc. One-var stats is number 1. Tell it to look at L1 first. Those are my X values. Then the comma. Remember where the comma is? Right up above the 7, the whole key above the 7. And then L2. And when you hit enter, it assumes.
Okay.
Oh yeah, yours looks weird because you got the newer operating
What do
system.
we do for that?
Your frequency list is L2. Okay, so right here. You guys have this one. So this is your X list. This is your frequency list. That's where your L2 goes in.
Oh, okay.
So it actually says frequency for yours.
And then you just press,
Calculate.
what is my list?
That means when you go back and look at your two lists, yours don't match up on the end. You missed one number somewhere. Yours aren't lining up. There's a dimension mismatch.
Wait, what?
Did we put the 0?
Oh, I forgot to put.
Oh,
Okay.
you didn't put L2 in, did you?
No, I put L2 and not L1.
Oh, well, there we go. We need two lists for it to look at.
Okay.
So I'll go back and do that then. Okay, here, I asked for the mean. What's the average number of kids per household? Where do I get it off of this one-bar stat?
The X bar.
The X bar. So there's 1.7 kids per house. Is variance on one-bar stats?
Yes.
No.
Okay.
But what is on here?
Variance squared.
Standard deviation is here. Which standard deviation should you be taking? The 1.47 or the 1.46? They're really close, but should I be taking the S or the sigma? Why S? Because I told you it was a sample of homes. Remember, the formulas are different. So we want the S, which is 1.474 kids per house. How do I get variance then from the standard deviation? You square that number. Is variance on here? Not a chance, because that's got those. It has those dumb units. Because this is going to be kids per house squared. Yeah, kids squared per house squared.
Ooh, that sounds like.
Yeah, kids squared. I don't know about that. So 1.474 squared. $2.173 kids squared per house squared. Okay, so that's how you deal with grouped data quickly.
Mine's still coming out different.
The answers are coming out different? If the answers are coming out different, that just
That was different. Like, from the beginning to end, that was different.
then that means you did not type in the numbers the way I typed them in. So you can quickly double check that if you want. Nope, not identical. They're computers. give it the identical thing to do. Computers don't make mistakes, only people do.
0, 1, 2, 3, 4, 5, 6.
Yep,
10, 19, 7, 7, 5, 1, 1.
yep. Now I'll go back to stat, calc,
Quit.
yep. One var stats, L1, comma, L2. You got to tell it L2. Do that part. I think you might have just done the one var stats on list 1, I bet.
What did you do? 1.7 was
Good now?
the...
Yep. You didn't put in L2, did you? No, I didn't think so. See, computers don't make mistakes. You give it the same data, it gives you the same results every single time. Austin?
Yep.
Give him 2 times 3, he might get that right 9 times out of 10. He's going to miss it once in a while, because he's human. All right, so that's group data. Let's see, what else do I have here? I don't want Chevy Chev. Oh, this one. One more group data. Okay, the wins. Number of wins. And the frequency.
I said there's only one.
I lied, there's 2. Okay, I don't know if this is over... I don't know, they got it grouped though. 3 to 4 wins. 5 to 6 wins. 7 to 8 wins. 9 to 10 wins. And 11 to 13 wins. And then the frequency that this happened, I don't know if this is per... I don't know what this would be, per season? That'd be bad.
Wait, how did it go from 9 times 2?
Because it must have come out exact. Anytime the class width, which is 2 here, if there was no rounding up, the last class is always 1 bigger to include that last number. We've got 5 times you got 3 to 4 wins. 6, 6, 7, and 6. I could look, I need to see what this is all about. We're going to. Page 82. I just want to check to see what these are. Page 82. Number 30.
Oh, go away.
The number of wins for each National Football League team in 1997 are listed. It says how many teams had that number of wins. Make a free. Katie's gone. Okay, we want to, this is for all the NFL teams. In the, what was it, 1997 season. You're going to estimate the mean,
I was born.
the variance, and the standard deviation.
Fun a little bit.
Okay, we want mean, variance, and standard deviation. Why am I calling this an estimate for the mean, variance, and standard deviation?
Does not have exact.
We don't have exact. Did they have 3 wins or 4 wins, these 5 teams? We don't know. We don't have anything exact. So what do we do when we have this range of values here? What did we use last time? We pick the middle number. We need midpoints.
Not with another column.
Yeah.
Oh, we'll do it over here. Midpoints over here. I left a space. You got to do exactly as I do. Jeez, haven't you learned anything yet? If I leave a little space, you know I'm probably going to write in it.
Make it feel dumb.
Put it over here. You got room over here? Put it over here.
Fourth grader to come help you.
3.5,
Oh, my bad.
5.5, 7.5, 9.5. What are we going to do here? Let's go 12. Let's actually use the midpoint. So we're not going to bother with method 1, which would be entering in, how many teams did we have here in 1997? 25 teams. You could enter all 25 values in. That would be the long way.
There's 30. I just got 90.
1997 looks like there were 25. Must have expanded. Because it's all the NFL teams represented. What, am I wrong here? 1, 2, 3, 4. Oh. Is there 30? 6 times 4. 1, 2, 3, 4, 5, 30. Oh, what the heck am I doing?
Where did you get 6 times 4? There's only 3 sixes.
Well, I stuck that one up there, but I didn't realize it made them all 6s. 6 times 4, when I added 1 instead of adding 6. That's what I did. This is what I saw. I took 1 away from that, threw it up there just to make this a 6. Didn't realize I was making that a 6 too. Don't worry about the method to my madness. It was wrong. Okay, so our trick, we're going to enter the wins into list 1. Enter the frequency into list 2. And then you're going to 1-bar stats that. But don't forget the comma for the second frequency list. Because we couldn't, well, do I use 3 or 4? I've got 5 teams that either had 3 or 4 wins. Do I use 3s or do I use 4s? We don't use either one, we use the middle as the best estimate. That's why it's an estimate. So this is not an actual mean variance. This is going to be our best estimate we can get based on the data we're given, because it's group data. So, midpoint wins. Midpoint wins. Oh, that's what you were. Oh, yeah. Midpoint wins. My mistake. I knew what you were. I didn't know what you were asking, but now I do. So. And then the frequencies. And then you quit and run your 1-bar stats. And don't forget, because it's a frequency, you need that second one. So 7.8 is the average number of wins. The variance we'll figure out in a minute.
Okay.
Yep. And then there's always 2 standard deviations, the population one and the sample one. Which one do we want this time? Do you want the S or do you want the sigma? Sigma this time, because it's all of the NFL teams. Not a sampling of them, but all of them. So 2.891. And then how do you get variance? Square it.
Okay, wait.
Okay?
So, standard deviation. We're doing what's it called, sigma?
Yep.
Because it's a population.
Because it's all of the NFL teams, which makes it a population.
And if it wasn't, then I would do the S.
S. Okay.
And then variance is always just
The whatever you get here squared.
standard deviation squared.
Yep. That would be win squared per team squared. Okay, now one more thing.
Wait, is our quiz is it solved that it's example or
Yes. You have to be told that. It's never just a guess on your part.
Hold on, I need to move on. I'm still on it. Up a little higher. Okay.
Okay. All right, this next thing and last thing, make this graph kind of big because I'm going to draw a lot of stuff in it. So we're going to make this graph next. And see, I'm going to write stuff in here and up here and down here. So you've been forewarned how large to make this so you can fit everything in.
We have to make that?
Yeah, we're going to make it right now.
Short. We only have 2 examples.
Yeah, this is it. We're doing this, and we're done. This one can be tiny though, but this one. Oh yeah, lots of time. We got to finish this. Okay. The empirical rule. That quiz is going to take you less than 5 minutes.
Bet you not.
I'll bet.
Bet you not.
the empirical rule, known as the 68, 95, 99.7 rule. So that just rolls off the tongue.
That's easy to remember.
Yep. Not yet, nope. Right here. Okay, so, and this works for symmetrical data only. And symmetrical, remember that symmetrical shape is that bell-shaped data. And this is what most of our data is going to be through the semester, is this symmetrical shape. So again, here's the big graph.
So we're putting stuff like above it, too, right?
Yep. I didn't leave much room there, but I can squeeze it in up there. You can put it below it too if you want.
Is there anything going below this?
No. Okay, remember you get the symmetrical shape when your mean, median, and mode are all approximately the same value. So your mean is your line of symmetry. And remember, standard deviation is the average distance away.
Okay, can you just wait?
Yep. Okay, and what we're going to do is move 1, 2, and 3 standard deviations away from that mean. How big is the standard deviation? Depends on the data set. But for this graph, I'm going to make the third standard deviation start about where it starts to tail off here. So I'm just going to estimate. I want a division about here. Keep that same distance here and here. Your third one should end right where it kind of gets close to the axis. And then you want the same 3 marks on the other side. Easy for me because I have graph paper here. So, are you ready yet?
No.
Not yet. Okay, we got to get going here. So what this empirical rule says is that if you are within, 68% of your data is going to be within 1 standard deviation of the mean. So what this first bar represented here was the mean plus 1 standard deviation, because I plus adding because I went above. This one represents the mean minus 1 standard deviation. So in between these 2 marks, these 2 big chunks, will contain 68% of your data. So if we had 100 pieces of data, just to keep it simple, 68 of them would fall within here. So what does that mean is on each side here? Because it's symmetrical. 34% on each side. 34% of your data is 1 standard deviation below. 34% is 1 standard deviation above. Okay? The 95% is what 2 standard deviations will contain. So this next mark out is the mean plus 2 standard deviations. So plus 2s. This one back here is the mean minus 2s. And then in between those, and I didn't leave enough room at the top like I told myself to. So if you have room above, those 4 chunks will contain 95% of your data. So it would be nice to know what's in each little piece here. And that's just a little subtracting. We've got 95 minus the 68. That leaves 27%, but then I'm going to divide it into two chunks. 13.5% in each one of those. And then our last mark out is 3, because it's 95 for those four. I've got 68 used up in the middle, so I did 95 minus 68, divided it for these two pieces. So here's the mean plus 3 standard deviations, and then here's the mean minus 3 standard deviations. Those 6 chunks contain 99.7% of your data. So if we do the math, 99.7 minus the 95 in the middle, divide by 2, 2.35%. So let's do an example with this and call it good. Let's see, the average height of an American woman is 64 inches with a standard deviation equal to 2.75 inches, and heights are symmetrical. Okay, I want you to make the graph according to the empirical rule, giving me the cutoff, and then I'm going to ask you a percentage question. So this graph doesn't have to be as big. I know that they're symmetrical, so I just want a little graph that's symmetrical. And I want those 7 values marked off in here. 1, 2, 3, 4. So you've got your middle one, and then the 3 above, and then your middle one, and the 3 below. So there's 7 key values that we want to talk about.
Where'd you pull 7 from?
The middle, 3 plus 3 above, plus 3 below. 3 and 3 is 6 plus the middle. I got 7 vertical bars there.
Oh.
Each bar. So, I mean, your graph doesn't have to look great. What's going on the middle bar? 64. The 64 inches. My mean is right on the middle. What do I do to get these 3 that are above it? That says 64. What's my process? Keep adding 2.75, because this is 1 standard deviation above, 2 standard deviations above. So this next one's going to be 66.75 plus 2.75, 69.5 plus 2.75, 72.25. And now how do I get the 3 below? Subtract. 61.25. 58.5. 55.75.
What are the last 2?
58.5?
No.
69.5?
Okay.
72.25. What percent are between 58.5 inches and 69.5 inches? How do I figure that out?
95.
It's that challenging. How did you get 95? Just looked at the chart above. Okay, so your assignment after the quiz. Let's see. Page 80.
After.
24 to 26.
Got it?
29 and 32. That's it. Okay, now